right, this is the Group 9 Mechatronics presentation. In our group, we had Christopher Green, Jorge Martinez, Andrew Scherrer, and I am Kelvin Sweetman. So our competition, we were doing a line following robot competition to try and see who can get as close to a wall as possible, also using an ultrasonic distance sensor. The robots would make a U-turn and then proceed to a wall, and the closest to the wall wins. The following slide is a video from that competition. Our group was on the left-hand side, and the other group is on the right-hand side. The other group did much better than us. And now I will hand it off to Christopher Green to talk about the code.
So in the code design process, there's basically 3 states that the robot can have. It can be currently seeking to try to find a line. It can be following the line, or it could be currently disregarding any lines and trying to seek for the wall. So basically in the seeking state, it just goes forward, and as soon as it hits any sort of a line, then it starts the line following algorithm. In the line following algorithm, it will check if all 3 sensors are reading black. If they are, then it will call the wall seeking algorithm. Otherwise, it will just keep following the line. Otherwise, if it is currently seeking the wall, then all it does is it goes forward and it checks the distance. And if it's less than some value, for example, 5 centimeters, then it will stop, turn left, and then it will go straight and start seeking a line. And with that, I will pass it off to George.
Okay, so the sensors we used were 3 line sensors, which allowed the robot to track the line we had set down, and we also used an ultrasonic sensor, which allowed the robot to detect the wall that was in front of it. And for our actuators, we used gear motors, which were used to rotate the tires, which allowed the robot to move. Going off to Andrew.
Okay, so as you can see from our video of the competition, we had quite a few problems, and here are some of our main problems. One was the motors. They were very, very inconsistent. So they would rotate at different speeds, and as soon as you applied a load to them, then one wheel would rotate a lot faster than the other, even though they were hard-coded to both the same values. So there was quite a few issues with that. One of the other issues was weight. This robot was kind of unbalanced, so it would put more load on one motor than the other. It was unbalanced because of the placement of the battery pack. And then it would rotate towards one side or the other and just kind of make the whole robot kind of sluggish. Another issue that we ran into was with the H-bridge. We had really weird control issues. And when you say if you're command both motors to go forward at 100% speed and you grab one motor, it would cause the other motor to stop. Or even if you don't grab any motor, then maybe one motor will rotate and then stop rotating. So it was just really, really weird issues. And we did check the wiring on our robot, and it was correct according to the schematic. And then one of our other big issues was with the line sensors. So we took care of the jitter or the noise of the sensor with a moving average filter, which was no problem. But the hard part is that the values that the sensor would center on, so for example, you would read like 150 plus or minus 20 when you're on a white surface, but sometimes it would read 750 plus or minus 20 when it's on a white surface. So there's no amount of moving average filtering that would allow us to detect whether it's on a white line or black line, because when it was on black, it would be around 700 or 750 or 800. So we couldn't choose a threshold value that would make sense for the code, because it could just randomly think it's over a black line when it's really not. So that's really kind of where a lot of our problems stemmed from in the competition. So, and we also did try to replace motors and sensors, and we even replaced the H bridge and double checked our wiring and stuff. So there's just some bug in the robot that we couldn't find. And now we'll pass it off to Christopher to do the conclusion.
So in conclusion, while the robot didn't work, that does not mean that nothing was learned. Teamwork was very important while trying to solve the problem, and we did learn a bit about communication and debugging code and whatnot with that. We were able at one point to get it to somewhat follow a line, but the line sensors were still not very accurate, so it wasn't able to do that for very long. It was fun trying to figure out a difficult problem. Basically, for this particular robot, we have to create a control system that does not actually have the feedback part of the loop.